Today we are doing lesson 4, solve multiplicative comparison problems with large numbers. So let's represent and solve multiplicative comparison problems with larger numbers. Sound good to you? Mm-hmm. Okay, well, that's what we're going to do. All right, close your books. They shouldn't be open. Okay. So books should be closed. Look up here. What do you notice? What do you wonder? Raise your hand when you have some answers. What do you notice? What do you wonder? Okay, Quinn.
I wonder why there's a face that says not finished.
Okay, that's a really good question. Why didn't they finish, right? Adley.
I noticed that they didn't put why it isn't finished is because they didn't put all of all 8 times.
So we know that she should have 8 times, right? Mm-hmm. And it looks like she just didn't quite get there, did she? Riker?
It's on line paper.
It's on line paper, yeah. Coral?
I realized that they showed their work, but they didn't do the answer.
Right. So they showed their work. It looks like maybe they ran out of room on their paper, and they should have finished those. They would have at least had their cubes, their model, but they also didn't quite get the answer. What could you predict is the answer? What do you predict, Vivian?
72.
Because 9 times
8.
Yeah, so yeah, didn't quite finish. All right. So, does the diagram show that Claire read 8 times as many pages as Noah? Does the diagram show that Claire read 8 times as many pages as Noah? Brooks?
Are we counting the ones that are crossed out?
I would say no.
Okay, well then, no.
No, right? Right? I would say no because it's crossed out. And even if it was, she doesn't have the right number of cubes, does she? Or he, whoever it is. Okay, so no. Why do you think the student who drew this diagram crossed parts out? Why do you think this student crossed parts out? Hadley.
I think that they probably crossed it out because I do this sometimes because they ran out of room on their piece of paper, or they didn't understand.
Yeah, I would say if they didn't understand, they were close to understanding it, weren't they? Yeah, so I think I agree with you. They knew what they drew wasn't quite right, so they crossed it out. What might be challenging about drawing each page when there are lots of objects? So we kind of ran into this yesterday. You guys had to draw 48. Why is that challenging, Quinn?
You'll run out of room.
You might run out of space, right, Kate?
You might lose count, and then
You might
be hard to draw. A bunch of 72.
Sure, 72 would be a lot to draw and a lot to count. Hadley?
Also it probably will waste time because if you're trying to finish it.
My teacher brain goes, is this really an efficient way to solve this? Is this a good use of your time? If we know our math facts, can't we just say 9 times 8 is 72, right? What other ways could you make a diagram to show larger amounts? Jerica? Aaron?
By using just drawing circles real quick.
So maybe circles are faster than a square. Okay, Hadley?
Maybe saying that is a cube is worth more.
Oh, so instead of each cube being worth 1,
it could be 5 or something.
What a good idea. Or 2
Yeah,
or something.
like
Yeah, I love that idea. So today we are going to look at diagrams that show comparisons with larger numbers, and we're going to think about when we might use them to represent and solve our own problems. All right, launch. Mai and Andre compare the number of pages they read on the first day of their reading competition. Ooh, they're having a reading competition.
Ooh.
Looks like Mai read 50. Oh, how interesting. What do you suppose this means? We've got a cube with the number 15 in it. What do you think, Gabriella?
I think the cube represents 15.
Is that what you guys were thinking? Okay, so that was kind of like Hadley's idea earlier. So, is 15 pages too high or low of an estimate for Andre? Look at all the cubes for Andre right here. Do you think he's read 15 pages? Is that too high? Is that too low? What do you think?
Way too low. Each square represents 15.
Yeah.
He has way more.
Way too low. If each of those squares is 15, then an estimate of 15 is way too low. If Andre read 9 times as much as Mai, what number should replace the question mark in the diagram? And why? Fred?
140.
How did you get 140?
Because if it was times 2, it would be 150. But since it's times 9, we just do 140.
Okay, so I'm guessing you knew that you would have to do 15 times 9. Okay, so you could do it the way Brooks did. That was some really good logical thinking. Guys, you could also break this apart. So if I was going to break it apart, I would break the 15 into 10 and 5 and multiply each of those by 9. What is 10 times 9, everybody?
90.
And 5 times 9? 45. And then if you add those together, what do you get? That would be 135. You were very close. I think that 5 threw you off a little bit. But yes, very close. So it should be 135, right? Okay. Let's see what we're doing today. All right. Isn't this what we just did?
Yeah.
Kind of. Okay. So very similar to what we just did. It looks like you have 4 questions. Okay. So this time you're going to come up with what would be a good estimate. We know 15 is too low, right? Okay. Guys, I'm going to say work with your math partner, and we're going to come back in 10 minutes, and we'll go over it. Aubriella, can you get the lights, please? Right. So, number 2. The diagram shows the pages Lynn and Kieran read on one day of the reading competition. A, complete the statement and explain how you know. So, Kieran read blank times as many pages as Lynn. So here's Kieran's pages, here's Lynn's pages. How many times as many pages did Kieran read, you guys? Emma? 6. I know Emma is correct because I see 1, 2, 3, 4, 5, 6. I have 6 cubes, right? 6 parts. B, write a multiplication equation that compares the pages read by Lynn and Kieran. What multiplication equation could you write? Riker.
9 times 6 equals 54.
9. So we know Lynn read 9 pages. We know Kieran wrote 6 times as many. So altogether, they should have read 50. Well, we know Kieran read 56, right? So that's going to compare it. How many total pages did Kieran read, everybody?
54.
54. Did you label your answer with the word pages?
Yes.
Okay. Number 2, pretty easy, right? Then we got to number 3. And things kind of got a little confusing. For some of us. Not all of us. We'll see. Okay. So Jada read some pages. Han read 60 pages altogether. Did you guys notice all of these question marks? Did you notice that? Yeah. But we do know that Han read 60, right? So A, how many times as many pages did Han read? Explain how you know. Okay, Hadley.
I said 20 because you pass by 60 if you do 20.
Okay. So I think I know what you mean by 20. So we know, erase. We know 60 split into 3 equal parts is 20, right? Do we all know that part?
Yeah.
Okay, here's where it gets confusing. How many times as many pages? So Jada read this one rectangle. How many times as many pages did Han read? Bella. 3. Okay. I know that because I can look at the diagram, and do we all know Jada read 20 pages? Do we all know that? Yeah. I can look at this diagram, and Han's pages are split into 3 equal groups. I also know Han read 60 and Jada read 20. So 20 times 3 is 60. So it would be 3 times as many. Does that make sense? That's kind of tricky to think about that. Isn't that weird to hear that times as how many times as many? It's almost a tongue twister, isn't it? Okay, then letter B was a little tricky. Write a multiplication equation to compare the pages read by Han and Jada. Use a symbol to represent the unknown. Okay, guys, the symbol is not a multiplication sign. Okay. Let's just see. What are we thinking? What are we thinking, Jerica? Raise your hand if you used a variable or you used the variable n. Okay. So, guys, we're starting to do some algebra. Okay. So we're writing an equation, and anytime we have an unknown number, we can represent it with a variable. A variable is just a letter that takes the place of a number. So, any letter could be a variable, but we like to keep them lowercase. And we like to stay away from x because x looks like what? Times. So I just kind of say always use n. Sometimes they give you the variable. Sometimes it's a J for Jada, H for Han, and that's okay. Quinn.
But if you do X, you can put a dot before it.
You could use the times symbol as a dot. You're right. And as you get into 6th and 7th grade, that's exactly what you'll do. Hadley.
Can you use a letter more than once in a time, like a multiplication thing?
In one equation?
Yeah.
What a good question. Only if it represents the same number. Otherwise, it's going to be impossible to solve. So, for B, to write my multiplication equation, to compare the number of pages. Well, if I'm comparing the pages read by Han and Jada, I know Jada read 20, right? So I'm just going to write mine down here. So I know Jada read 20 times, well, I know the answer is 3, but if I'm using a variable, I'm going to put n equals 60. Okay? All right, so here is Jada, here is Han, and when we compare them, we can say that Han read 3 times as many pages as Jada. So then for C, how many pages did Jada read? How many pages, guys?
20.
20 pages. Questions for number 3. Okay, there was a whole lot there. It's kind of tricky. All right, we're going to look at number 4. Elena read 72 pages. Claire read 9 pages. How is this diagram different from the earlier diagrams? Madeline?
This diagram has no blocks on it.
Right. We don't have all of our cubes, right? So it's just a bunch of dotted lines. So let's look at B. Write a multiplication equation to compare the pages read by Elena and Claire. Use a symbol to represent the unknown. So we're going to have a variable, right guys? Okay, Quinn, what did you come up with?
9.x equals 72.
Okay, so I'm going to say n, okay? But yes, you're also correct. So I can say he's correct because Claire, we know she read 9 pages, right? We know Elena read 72 pages. So here we have Claire, here we have Elena. We're comparing them with times n, which brings us to C. How many times as many pages does Elena read as Claire? Keston.
8.
We know it's 8 because n will equal 8, right? Because 9 times 8 is 72. So how many cubes would I have drawn in here? 8. Okay, press.
Could you also put 72 divided by 9 equals 8?
You sure could do. You could do the inverse. You could do division, right? Very good. Inverse means opposite. Very good. Okay, let's look at, guys, we just synthesized. All right, we're going to look at activity 2. Guys, for each situation, write an equation to represent the situation. Use a symbol to represent the unknown. That's going to be a variable. I would like you all to use lowercase n. Okay? Then it says draw a diagram to show the comparison. Okay? We're using larger numbers. So could you have 1 cube be worth like 15 or 9?
Yes. Yeah.
Okay, so you can look back at activity 1 for examples. Do you have to draw a diagram?
Yes.
Yes. and then answer the question about the situation. What will we do with each problem in this task? Didn't we just talk about that?
Yes.
We will do these things that Mrs. McElroy just said, right? Okay, it looks to me like you've got 1, 2, 3. You've got 3 questions. I'll give you guys, again, about 10-ish minutes. And then, all right, guys, we are going to go over, I want to go over question 3, okay? So we're looking at number 3. Is everybody looking at 3? Okay. Noah read 13 books. Elena read 130 books. I had a couple kids panic and ask if they had to draw 130 squares. No, that is a horrible use of your time, right? So, first we're just going to write our equation. They've given us 13, which is how many Noah read, and 130, which is how many Elena read. Those are the two I'm comparing. We want to write our equation using a variable. What letter do I want you using for a variable, everybody?
Lowercase
N. Lowercase n. So, I'm thinking to myself, okay, 13 times some number gives me 130. Because when I compare them, I'm doing times as many, right? Okay, then it says diagram. This is where we started falling apart. So I'm going to draw my diagram in this box over here, okay? For your diagram, we kind of talked about this when we were talking about graphic features in reading. If it's a diagram, you have to label it. Some of you guys just went crazy and drew a bunch of squares. Okay, that doesn't label it. So you're going to label it with people. So we're comparing Noah, and yes, you have to write his name, to Elena. Okay? It's like 4 or 5 letters. I'm sure you will survive. Okay? So we're comparing Noah and Elena. Noah read 13 books, which is way less than 130, right? So here in your equation you have 13 also. So I could decide, okay, I'm going to make one square and it's going to be worth 13. So then when it comes time to draw Elena's diagram, she had 130 books, right? Do I really need to draw 130 squares? No. If Noah's square is worth 13 and I'm comparing him to Elena, then each of Elena's squares also has to be 13. And then I'm thinking to myself, how many 13s are in 130? What is it, everybody? 10. So I'm going to draw 10 squares, and I'm going to write the number 13 in each one. Just like our earlier example, I'm running out of room. You guys had more space than me, but I could continue down below, right? And I know she's going to need 10. So there's another 5, and I'm going to put 13 in each cube, right? Now, do I have 130? I do, because 13 times 10 is 130. So here's my diagram. Complete the statement. Blank read blank times as many books as blank. Who can fill it in for me? Emma.
Elena read 10 times as many books as Noah read.
Elena read 10 times as many books as Noah. Guys, do you have any questions? Okay. Couple new concepts today. Letters as variables representing the unknown, right? So you guys did some algebra. We're doing this now. Each cube can be represented or worth a different amount, right guys? Okay, let's see if we need to synthesize. What information did you use in each situation to know how to draw each diagram? Turn and talk with your neighbor about that question.
How many books you
Okay, so I have this strategy. So it tells you your information. Then you try to make an equation with that, and whatever information you're missing is how you solve the problem. So if you're missing one of your factors, then you're going to divide the two numbers. And if you're missing your and product, you are going to multiply the two numbers.
Oh my gosh. Yes. All right, raise your hand to share. What information did you use so you could draw your diagram? Hadley. Mostly you used your equation, okay, because your diagram really should match your equation. Yeah. Kate, what did you use?
I also used what I knew about multiplication so then I could know what numbers that I needed to use to, like what numbers I would put in this equation.
Right. So knowing your math facts was probably extremely helpful. Michael.
I knew that whenever you times by 10, it just adds another 0 in third.
So knowing that little trick with the zeros probably speeds things up. How was the last problem different from the other two? How was the last problem different, Jerica? You did! Chase.
It has the complete the statement.
It has what?
The complete the statement.
So you had to complete a statement. What else was different? Okay, Erin?
Elena had the most books of all the others.
Okay, so we had the biggest numbers. Okay, Hadley, what are you thinking? Oh, that was yours. Okay, Michael.
One of the numbers were in the hundreds place.
Yeah. So I'm noticing it tells you in number 2, 12 times as many. And in number 1, it tells you 8 times as many. So for number 3, you had to figure out how many times as many, didn't you? So that was definitely different. Okay. So, today, guys, we worked with variables. We drew diagrams. You're going to go back and you're going to do your cool down. Look, freeze. I already see people getting up. When you write your equation for number 1, make sure you use a symbol, aka variable. So you're going to write me an equation with a variable and you're going to solve it. All right, guys, that was lesson 4 of Unit 5.